Every year, small-scale farmers in underserved regions lose about 30 to 40% of their harvest value to broken supply chains, while consumers pay 3 to 4 times more for food that has traveled thousands of kilometers. This creates a rise of 100 billion US dollars annual loss in farmer income and contributes to 8% of global carbon emission from food transportation alone. Good morning, good afternoon, good evening, depending on your location. My name is Localbite. I'm a software developer. Today I'm presenting my software application, which by the title named Localbite is a farm-to-table marketplace. Now, what is the objective? The objective of this application is to solve critical disconnection between small-scale farmers and conscious consumers through an AI-powered intelligent marketplace. Now, they have current issue on ground between farmers and consumers. The farmers lack market access, which force them to sell through intermediaries, of course, which are the retailers. Those retailers, the farmers lose up to 40 to 60% of revenue. Consumers as well has limited access to fresh, local, sustainable source food. No transparency about origins. Now these supply chains, they have high waste, inefficient routing, high waste of 20 to 30% because of the supply chain, poor freshness, disconnected demand forecasting. Community, there is food scarcity, local economic decline, dependency, and imported goods. There are gaps in the economy right now that is affecting the consumers and the farmer. There is a big gap. Now this software is going to bring solution to those gaps, those loopholes. One of the gap we encounter is generic marketplace. Currently there are generic marketplace, but with the help of this application, we'll have a location aware matching. What does that mean? It means that every user will be matched according to their location. So if you are staying in Lagos, for instance, you don't have to purchase something that is not in your territory or your location. The software or the model is going to match you with the farmer who produces that particular product you want in your location closer to you. That's what this is talking about. Farmers, now currently we have farmers database. Now with the help of this software, it is going to be intelligent recommendations. Currently we also have delivery service. Now with the help of this software, we'll be having demand forecasting. Now currently there are manual logistics, but with the help of this software development application, we are going to be having route optimization and plus quality scoring. Now, why is this application coming right now in this time, in this era? Because there is technology breakthrough. Real-time matching algorithm. There is a real-time matching algorithm. Machine learning forecasting and route optimization are now accessible and affordable. That is why this is the right moment for this kind of application. Post-pandemic shift to local economies, there is an addition of 45% growth in local food system from 2020 to 2024. There is also 75% of consumer prioritizes sustainability, willing to pay premium for food, traceable food. And also, government incentivized for local food system and carbon reduction. Now this application falls under four SDGs. It falls under four sustainable development goal. And the first SDG it fall is known as zero hunger. Because with the help of this application, it's going to provide and strengthen local food system for vulnerable populations. And it will increase farmers' income. It sensitizes local production and improve food security. This application also helps the community to have a reliable access and affordable to nutrition food. The second SDG that this application fall into is known as decent work and economic growth. Now, it empowers small-scale farmers with fair income opportunities. Now, they don't have to lose all their money to the chain of distribution. They have the opportunity to interact directly with the consumers of their products. Then this application also eliminates intermediaries because farmer is going to keep about 70 to 80% of sale price, which is economic empowerment. There will be a 30 to 50% income increase for 10,000 plus farmers within 3 years. Another category of SDG where this application fall under is the responsible consumption and production. With this application, there will be a reduced food waste and environment impact. And there will also be an access and opportunity for a direct supply, accurate demand forecasting, 40% less spoilage, plus 95% lower carbon footprint. The outcome is that we will have a sustainable, transparent, and local source food systems. The last SDG that this application fall under is the sustainable cities and communities. Now, with the help of this application, we will build a local and resilient food infrastructure, connecting urban consumers to nearby farms, strengthening the local network. Also, the community become food sovereign with economic resilience. Now, I am solving this particular problem, which is the farm to consumer, which bring about this disconnection, and I'm solving this with AI, powerful AI marketplace with intelligent matching, demand forecasting, and route optimization. This matters because farmers lose billions to broken supply chain. Consumers can't access fresh local food, and communities face food insecurities. Now, someone will ask me, why are you actually building this? I'm building this because technology can directly empower marginalized producers, rather marginalized producers, create healthier communities, and prove that scalable solutions serve both profit and purpose. So, my solution design for this particular product goes below. There are four core intelligent algorithms used in this application. The first algorithm used is known as smart matching engine. What does this mean? It is it is very intelligent that it connects farmers with consumers based on preference, location, and product availability. What this is talking about is that with the help of this powerful intelligent AI, every consumers at a particular region will be matched based on the user's preference, location, and product availability. So it therefore means that a user who is in Abuja will not match to the same farmer that is in Lagos. It means that every users will be matched with their preference, their location where they are. The system will automatically match them to the nearby farmer who provide exactly the product available in that particular region. Of course, the user preference. So that is what this particular algorithm provides. Now the first algorithm, for instance, we have a real world example. This is a health conscious consumer in New York. The person comes from New York. A user can log in and he searches for organic vegetable. Look at what the algorithm do. The algorithm will find farmers producing organic goods or vegetables within 50 kilometers. That means it will find the farmers that is in this region within 50 kilometers. Now it will rank them based on past positive reviews plus seasonal availabilities. Of course, if a farmer is doing well, he will be ranked above other farmers. Now it will show a personalized recommendation. A personalized recommendation, meaning that what will be displayed to user A will be different from what will be displayed for user B. Their outcome or their output will be personalized based on their location, their preference, and their product availability. Now going further to the second algorithm. The second algorithm, which is known as demand forecasting time series analysis. This algorithm predicts consumer demand accurately so farmers can plan production and minimize waste. Very important, because in the essence, the farmers at the end, we want to minimize waste and maximize profit. So this algorithm will help the farmers to actually predict what the number of demand for a particular product, which will help them to increase production or to reduce production. Now, with the help of these algorithms, we'll be able to reduce food spoilage and ensure consistent supply, also help farmer optimize production. So going further, we will now go to the third algorithm. Now before going to the third algorithm, this is just a simple real world case study for the second algorithm. Now, for a farmer producing tomato, there will be a historical data that shows 40% increase in tomato demand within March and May, within the range of March to May. So at that time, the algorithm will predict, and the farmers will know that at this particular time, this is where they will have an 40% increase in the tomato demand. Also, weather forecast March temperature, which is 5 above average. Prediction: tomato demand will increase 50%. Farmer action: oya plant 50% more tomato seed. Then the result, there will be no waste, there will be maximized profit, and consumer will have consistent demand rather. The third algorithm, which is route optimization. Route optimization optimizes delivery in different routes that minimize cost, time, and carbon footprint. So this algorithm is actually going to help reduce the transportation and the cost of transporting goods from one location to another. So it will find the closest or the easiest route that this product can reach the consumers without spending more money on transportation. That's exactly what this is doing. Now this is the case study. Let's say a consumer ordered for 50 made order for 50 cement, or rather sorry 50 let's say 50 buckets of tomatoes. All right, now without optimization, that is the manual routing, the total distance might be 287 kilometers, and the time spent will be 8 hours, and it will cost $180. Now with this application, with this algorithm, the total distance will reduce 40% to 172 kilometers, and the time spent will be 4.5 hours, cost reducing by $108. Now, the last machine learning algorithm that we are going to integrate in this application is known as quality scoring system. Quality scoring system. Now this application, or rather this AI, helps to build trust through transparent quality metrics and farm reliability scoring. What this means is that there will be a review and there will be a scoring with some quality metrics on farmers that will rank the farmers according to their performances. Now some of these performances are order fulfillment rate. If there is order fulfillment rate and on-time delivery rate. Also, customer rating, return or refund rate, product freshness score, certification. Some farmers with certificate can provide their certificate in the application, and it will boost their ranking. The time of response also will boost their ranking. Product consistency, customer review sentiment, historical trend. All these are inputs or factors that will help us rank the performances of every farmers of the application. And we will do this through the help of quality scoring system, machine learning classification. Now, this is a real-world practical example or case study. Two organic farms in the same city. All right. Farm A, who is Joe Organic Garden. The fulfillment rate is 98%. On-time delivery 97%. Customer rating is 4.5 all over 5. 200 review. Certificate, there is 2 certificates provided. Quality scoring 92 over 100. Perfect. This amazing. Then Farm B, Green Valley Farm. Fulfillment 82%, which is lower than the first one. On-time delivery 75%. Customer rating 3.2 over 5, 50 review. No certification. Quality score 58 over 100. Customer sees both options rank by quality. They will choose based on priority, price versus reliability. Yeah. Now, the next thing that we are going to do is to actually visit this site and see the application itself. In the application, we have farmer dashboard and we have users dashboard. So with no further waste of time, we are going straight to the application itself. Now, to ensure that my code is running perfect, is running, and I will now move to the browser, and boom, this is the application. This is the home page, the Localbite. This is home page. Fresh food direct from nearby farms. We support local farmers, eat fresher food, and cut the carbon footprint of every meal. Localbite connects you to trusted farm in your area. Now, if you're a farmer, you go straight to the farmer's dashboard. Permit me to say at this point that this application currently does not have back-end integration. At this point, we are on the front-end development. So, but after this step, or after this development, we'll move into the back-end where we are going to integrate all the AI we've discussed about. So, but for the purpose of this video, and at the time of making this video, we currently have only front end for now. I'm not saying anything. Make I pause this thing. No, it will pause this thing. So I'm not saying anything. So this is the dashboard. Sorry, rather this is the home page. As you can see, we have a beautiful user interface, which is also mobile responsive. So these are some of the products that we have currently in the application, which of course, if you want more, you can go to the browse product. So let's quickly go to the browse product and see the products that we currently have in the application. So these are the application. We have them by categories. We have all products. We have vegetable. We have fruits. As you click them, they display according to the one you click. So these are a list of products that we have here. Then if you are a consumer, you can go to your dashboard, because every user has their dashboard where they manage their transactions. Of course, if we have back end, of course your name will display here. and we have your active order, we have your total order, your favorite farms, and maybe reward points as well as. Then you have recommendation based on the AI we integrate. There will be a recommended for you to check out. So uh, this is what and how our user dashboard looks like currently. And as well, you can navigate to the farmers dashboard where you will see a couple of things here. This is dashboard. In the farmer dashboard, we will have a quality score. Remember, our AI model will help us score or rank each farmer. So to do this and display their score here, then these are the performances total and quality score, active product, on time delivery. These are some quick action. You can manage inventory, you can view orders, you can show your analytics. So inside manage inventory, this inventory management, you can see total product, you can see total inventory value, total unit. Then under here you see your product. So the more you upload products, the more they show here. And each product have category, has price, it has the quantity available. It has rating and action. You can delete and you can update. Then of course, when you come to the order page, these are the ones that user has ordered. So we'll have the order ID, the product name, quality, the amount. Then analysis, you can also analyze. So you have the analysis. You can analyze every transaction that happened in this site. Here is where you now see the review and the rating from users. Then of course, your profile should be available to you. This is your profile where you can change your name and location. Now, when a user log in for the first time, we have two login sessions. Is either you log in as a farmer or you log in as a consumer. So initially, before you log in, you have to sign up. So on signing up, you'll be asked if you are a farmer or you are a buyer. If you are a buyer, you choose this first one, which is buy fresh products. If you are a seller, you choose sell my products. So if you are a farmer, if you are a buyer, your information will be different. You have to provide your name, your contact information, delivery address, the address where the goods will be delivered to. So you have to be careful in this place. You have to put your correct address and you register. But if you are a farmer, you select sell my product. So in this place, you provide your business information, your business name and the owner name, of course the contact address, your location, accurate location. Then if there is any certificate, it's optional, that you use to back up your business, you can as well select it from here. Then you put security, your password, you secure your account and you register. So this is how you can register for this application. Like I said, currently just have the front end view of this application. So this is the about page. To actually show you that it is user responsive, you can go to inspect and you can see that it is mobile phone responsive, so it can fit into any device that you are using, whether iPhone, Samsung, Android, you'll be able to, whatever you are using, you'll be able to see this perfectly aligned. So back to the home page. At the end of this project, at the end of this application, we are going to have a comprehensive web development application with AI integrated that will help us to track and to actually bring solution to the disconnection we have already between small-scale farmers and conscious consumers through an AI-powered intelligent marketplace. So this is the project structure for this project, and this is the folder tree, the Localbite, which becomes the root directory of my project. Inside it I have source folder where all source code live. Then inside source I have app where you see the layout.tsx, the main layout. This layout is where the designs and the structure of the project, the whole project looks like. So it contains the main layout, header, footer for all pages remains the same. This is where you set those information. Then you have the page.tsx, and this is the home page. This is the room directory, the page directory. And this is global CSS. This is the global style for all the pages, the global style. Then inside the root directory of apps, we have auth. This handles the authentication for the page, for the websites. Inside auth, we have login and we have register. Each of them has their own page. And login page, you go to auth/login. Register, you go to auth/register. Then we also have consumer page. Here we have their page, which represent the main home page under this consumer. Then we have discover. This is another page inside consumers where you can browse all the different products available. Then we also have other inside consumers page. Then we have farmers page. Inside farmer page we have farmer layout. We also have inventory, we have order, we have analytics, and we have profile. Each of these has their own page .tsx. Then we also have about support page, we have privacy page, and we have terms, which is terms and condition, terms of service, and we have policy page. Now going further, we have components. Component is actually where we define some functions. Of course, component means some functions that can be reusable by React. So we define some functions which in this term known as components that can be reusable across all pages. We define them here. Then we have library that holds data. This mock data.txt is a fake data because currently we have not yet integrated the back end. So we have a fake data for the process. Then we now have, under this library, we now have algorithms. These are the four algorithms we discussed about. Here is where we have the algorithm code. Then types, we have index.txt. This is the TypeScript type definition. Public is where we save all our images we use in the project. Then this is documentation. Every of our code is being documented in one after the other in the project. Every code is being documented so that it will be easier for to understand the workflow, and also helps developers to actually know how this project was developed in case they want to collaborate, or in case they want to help in the future development of the project. Then of course here we have package.json, which in this place define the dependencies used in this project. We have TypeScript configuration, which actually configure our TypeScript. We have next configuration, we have tailway configuration, post CSS configuration, ESLint configuration, and of course we have a readme file. So this is actually how our project looks like. The project structure looks like. Now going further, we'll have this is the further explanation of all these things. Source app. So if you go to this route, you meet the home page. Go to this route, you meet the authentication login page. Go to this route, you meet the consumer page, and you meet the consumer discovery page. Here you meet the farmers page. Here we meet the farmers order page. Why this structure? URL matches file structure, easy to navigate. Each page.css is automatically a route. That is there's a new feature by Next.js that makes every route, every page you create, a route. There's a nested folder created nested folder creates nested URL. Very organized and scalable. These are the advantage of this structure. Then the components page, which is usable UI pieces. These are the components we have currently, and each component has its own work. It stands as a function or a component that beautify the UI. Then going further, we'll have library, helper code, and data. This is where some scripts will be written and some data will be fetched. So in case we have a fake data that contains the information that we have gotten from the algorithm when we implement that. And this algorithm, then we have TypeScript. Of course, we have the TypeScript configuration here. This is how the file connects. The home page shows some link. It shows consumers, just like we have seen when we display. It shows consumer dashboard. When you click on it, you browse some products, and inside that you can see discovery, product card component, issue mock.product data. So this is exactly how the project work. So these are some file naming conventions which I felt will be necessary because it will guide me. All these are understanding the structure for beginners, so I made it very easy for beginners to really understand it. Route, source / app. This page, the page user see. Each folder one route. Each page the content. So Its component, reserve UI page, use in multiple pages, get data via props, change the state. And this is exactly what it does. This is a physical example of this. User goes to this page and it load. Then page import mock products from this data. Then page render product component for each product, and product card display product details nicely. User sees beautiful product listing. Let's see if we can practicalize this. Now let me run this code. Let me run this code. How to practicalize this? So next step is, okay, this is the next thing to read. But before we go further, let's practicalize all I've said. So before we continue, npm run dev. So this exactly is it. So it says user goes to consumer discover, control C. Slash. So I leave it to load. Then page load. So let's leave it to load. While it loads, let's go over this to this let's go over to visual. Yeah, let's go over to this guy. Let's go over to this guy here. So this is the visual reference guide. Let's quickly go through this. There is a problem here. Remove one. Enter. So here we have the Localbite learning pathway, module 1. Okay, this is problem discovery, architecture overview, build matching. Module 4, demand forecasting, route optimization, capstone integration. So these are my learning pathway. This is the diagram, 3 level of impact measurement. So this is measurement framework is for me for the algorithm which I am about to work on. Then we have engagement method that work, real local data, generic example, farmer in hypothetical town meet Amina. She grow tomato in Nairobi, meta era. Here is her actual 6 month sales data. Results, relevance, emotional connection, transferable. Here is how much algorithm work. So all these things are the measuring tools for me for this algorithm. Teaching execution timeline. This one is learning outcome distribution. So all these things are guides for the algorithm. Engagement versus outcome correlation. So these are what I will be integrating for the back end and the algorithm. So that is that I wanted to just show. Then going back to this this guy here. Go to architecture. Is not it. Going to routing and page. I think it's this guy here. No, it's not this guy. Project structure, yeah. Project structure. So yeah, you see we have opened the consumer discovery. So let's see the next thing that it asks us to check. Then after it loads, the page imports mock data from this, which is what it has done. Then page render product card components each product. So at this point, I want to appreciate everyone that have listened to me, and I will also want you to just stay tuned as we will be getting more updates and more information about this project, because currently we just have the first version of this project, which is the front end view. The next integration will be the back end, and of course we will implement the AI model we discussed about, and we will host this particular project, and we will begin to solve problems that is currently um, that's currently happening and currently affecting the farmers and also the buyer, even the community at large. So I remain your developer, Mr. Levi. My name is Levi. I remain Mr. Levi, and I wish you well. Thank you for listening to me, and goodbye for now.